Computer Science A, Unit 7 Array List, Lesson 6, Insertion Sort. The objectives of this lesson are to understand how the insertion sort algorithm orders an array of data and to understand the advantages and disadvantages of using the insertion sort algorithm to order the elements of an array. While it is unlikely that you'll need to code an insertion sort from scratch, it is important that you recognize an insertion sort and understand how it behaves. Just like the selection sort, the insertion sort looks through each element of the array in order. However, it differs by comparing the current element to each one that comes before it until it finds an element less than the current one. When that happens, it bumps each element after this point down the array by one spot and inserts the current element into the correct spot. By operating this way, we know that the beginning of the array, or the elements in the array before the current position, will always be correctly sorted. The algorithm proceeds through the array this way until it reaches the end. Let's take a look. The detailed steps of the insertion sort are as follows. Start with a pointer variable at next equals 1. Going backwards, inspect each element until you find one that is less than the value at the position next. Insert array next at this position, increment the index. Increment next. Repeat this process until you reach the end of the array. Let's see how it works. Okay, let's examine this in action by applying the insertion sort to this array. 56, 34, 55, 12, 88, 37, 45, 12. Does a switch need to happen between 56 and 34? Yes. So 34 goes down. Where should this be inserted so the list is in order? 55 should go between 34 and 56. So this compares with 56 first, then 34. So it's going to keep going. Now, notice we've got 34, 55, we're up to 56. This is all in order. So now we're up to 12. At any point in this insertion sort, everything to the left of the current index is sorted and everything to the right is not. So again, we start here at 1 and we assume 56 is sorted with 56. But then once we look at these two, we swap and the next becomes 2. So we're looking at 55, but 0 and 1 are in order. Okay? Now, here's another visual from www.geeksforgeeks.org insertion sort. And this shows you what's happening. You start with the original one. 4 is good, but then 3 gets moved in front of 4. Then 2 gets moved in front of 3. 10 is in its correct spot. So then we move on up here to 12. 12 is in its correct spot. We move to 1. 1 has to move to the front. 5 moves between 4 and 10. 6 moves between 5 and 10 on the next pass. And then 10 and 12 are in their correct locations. Now, again, you will not need to replicate this code from scratch. It is a good idea, however, to look through it and make sure you understand how it works and be able to recognize it. Okay, so an insertion sort. Start with the pointer at index set to 1. Remember, 0 is already where it needs to be. Now, int key is equal to the input at this location. Int j is set to I minus 1. So we go back 1. While j is greater than or equal to 0, and input j is greater than the key, input j plus 1 is set to the input j, going backwards one element at a time until the element reaches the end or the element is no longer greater than the one before it. Okay? So again, you don't have to replicate this, but you need to look through it. And a good thing to do is to cut out some numbers and play with them. Because I can stand up here and talk, or sit here and talk, and you can watch this video and listen to me yammer on. But it's hard to understand it unless you stop, cut out some little squares with numbers on them, mix them up, and then follow this through. Okay? Understand what's going on. Now, both of these sorting methods take about the same amount of time to sort an array. On the AP exam, the selection sort and the insertion sort are the only sorting algorithms you are expected to know. Others, like the merge sort, bubble sort, etc., are not required for the AP exam. That said, the merge sort and bubble sort are extremely useful and in certain situations, much more efficient. If you continue your study of computer science, you will learn more about these sorting algorithms. These sorting algorithms used to be part of the Comp Sci AB curriculum years ago when computer science was made up of 2 years instead of 1. This concludes Lesson 6.